Welcome once again to Isifeedublog. Now, in this particular video, we'll be treating the last practical you are going to see in the hall, which is your electricity. And this question actually concerns the meter bridge. But before I venture into this, if you are new to the channel, please subscribe, share, click on the notification bell for next or any notification of new uploads. Now, what we have here in this particular video is a setup of electricity practical concerning a meter bridge. And that is exactly what you'll be expecting in the hall. Now, this is the setup. I'm going to explain how this is done, although the practical is already done. And I'm going to show you the table. So let's read and see what they want us to do here. Now, the question goes like this. Connect the circuit as shown above. So this is the circuit we have. They say connect the circuit as shown above. Set the value of R, this is R, equals 30 ohms. So the first practical, now, anytime you have an arrow crossing a resistor, it is telling you that that thing is a variable resistor. We have two types of resistor. So we have standard resistor and variable resistor. So this is a variable resistor. In this case, this variable resistor is a resistance box. So it will be mentioned in the hall. We are given the following apparatus: resistance box, a key, all these things. So this is the resistance box. So as you can see, the resistance box is connected in parallel to this particular resistor. Now in the hall, this particular resistor will be closed. That's what I mean by closed. I mean it will be covered, maybe with sellotape or something like that. But what this, you call it unknown resistor. Why this is a known resistor? So this one that is not unknown is actually 1 ohm. But in the hall, it will not be told that this is 1 ohm. They will just use sellotape to close it. So they can call it X or any value they like. Okay, now watch. This is connected in parallel with the what? The resistance box, which is the variable resistor. While the 2 ohm resistor is connected here. I hope you can see that. Okay, connected in series. Now let's continue. So the first practical says, after you have connected this, now if you want to connect the galvanometer, which will also be provided, please, the positive terminal of the galvanometer has 2 terminals. You are going to see the positive one, plus, and the minus. So the positive terminal, use your wire and connect it to this part of the resistor. This variable resistor has, 2 terminals. So use this and connect. The positive goes to the negative part of this, while the other negative goes to this. That's how you connect that. Okay, now, why the negative terminal? The negative terminal of the galvanometer, negative terminal, connected to your jockey. This is jockey. This is the jockey. In case you want to do the practical in the hall. But if you don't want to do the practical, it's already done for you. You just copy and paste it in the hall for you. Just multiply or plot your graph. So you use the negative terminal, connect it to the jockey. Now what is the jockey? Looks like a pen. What is the function of this jockey? You use it to, you place it on the meter rule. This is meter rule from 0. This is from 0 to 100. 100 cm. So use it to place it on the wire on the meter rule of the meter bridge. The wire on this meter of the meter bridge. So let's continue the practical. So the first practical we are going to do is you remove 30 ohms from your resistance box. You remove 30 ohms from your resistance box. Once you do that, you keep that stuff, then come to your key and close it. Close your key. Remember, this is 3 volts. Your battery is 3 volts, 1.5 plus 1.5. So this is will give you 3 volts. Use your sellotape to guide it. Remember the negative terminal you connect it to your key. Now your key does not have positive or negative, does not matter anywhere you are connecting, but negative to this point, while positive you connect to the other end of the what? Meter bridge. It's a very easy connection. Now how you know that your connection is right is if you remove your 30 ohms from your resistor box, you start from here to place your jockey on the wire of the what? Meter bridge. Watch the deflection. Watch the deflection on the galvanometer. Now, if the deflection is going left-hand side, that means this is very, very correct connection. But if you place it and the deflection is going this way, that means you got the connection wrong. So be very careful about that. So let's say that you understood what I did and you connected well. So as you are placing your jockey, coming up, it will be deflecting, coming. At a point, you find out that the indicator in the jockey will be at 0. You call it in physics null deflection. So at that point where it is null, that is at 0, you record. That is your L. Remember, you are coming this way. So let's say we are going this way from 0 to 100. Be very careful. So I'm teaching the first practical. From 0 to 100 now, at 30. Now we have R. The first one is 30 ohms. So R is measured in ohms. And we have L in cm because we are calculating this from a meter rule. Now, but from the practical, L is from here to here. From Q to T, that is L. Not from O to T. So, but if you are bringing your hand, you are not coming this way, rather you are going this way. So what does that mean? From here to here, let's assume that where you have null deflection, that is where your galvanometer is at 0, is in 57 cm. For instance, from here to here is 57. Common sense should tell you, from here to here, which is your L, according to the practical, is what? 100 minus what? 57. Is that easy as that? So that is how to calculate L. So you can quickly say that L is equal to 100 minus OT for easy remembrance. So anything you get from O to T, subtract it away from what? 100. You get what? L. So let's just finish the practical. That's how to perform the practical. Now, they now say, set the value of R equals 30 ohms. We have explained that. Close the key and obtain a balance point T. That is where your jockey will be, where you have no deflection. That is where you call a balance point T on the meter bridge wire. On the meter bridge wire PQ. Meter bridge wire PQ. You can see that. Read and record the length TQ equals L. Read and record the length TQ equals L. So TQ equals L, not OT. As you can see that. So TQ is just 100 minus what? OT. That will give you L. Okay, we continue. Evaluate L raised to power minus 1 and R raised to power minus 1. So in each one, that one is use a calculator to do it. Then repeat the experiment for R equals 20, 10, 5, and 3. So what does that mean now? After doing what you did for 30, you now remove what? Go back to your resistance box, remove 20 ohms. Are you getting it now? So you fix everything back then, you now remove what? 20 ohms. If you remove 20 ohms, you also pick your jockey and be placing anywhere you have your deflection to be 0, read it, subtract it away from 100. That is L. That is the practical. After that, you do for 10, 5, and 3. So let's quickly jump into my own table after doing the practical. Let's see what I got for my L and my table. So our table is going to form also 4 columns. We have R, L, r raised to the power minus 1 and l raised to the power minus 1. Now from there, we are now told to plot a graph of r raised to the power minus 1 on the vertical axis against l raised to the power minus 1 on the horizontal axis. So let's do the table and the graph. So let's see how it looks like. Now, this is the outcome of the practical. So this is the table of values. The table of values for this practical. Be very careful so that you don't lose marks in table of values. We call it composite table. If you watch closely, this column is in 1 decimal place. Please present it exactly the way you are seeing it here. This is measured from a meter row, and the correct precision, the best precision for a meter row is 2 decimal places. If you leave it in 1 decimal place, there's no problem, but the best precision from a meter row is this. Now, for calculated values are values that are not gotten directly from the practicals. Rather, they are gotten from your calculator. These are what you call calculated values. And calculated values are supposed to be in at least 3 decimal places. At least 3 decimal places. So we have 1, 2, 3. You can make it 4. You can make it 5. There's no problem. But at least 3 decimal places. You can see all of them. This is 0.1. But I had to put what? 0, 0. So that it will be 3 decimal places. This is 0.2. I had to put it. This is 0.05. For me to make it 3 decimal places, I added 0. So that I have consistency in what? Decimal places. Same thing with here. Now, from the question, we are told to plot this R inverse, that is R raised to the power minus 1, against this. So this is on the vertical axis, while this is the horizontal axis. This is the outcome of the graph. Now we have our correct marking of axis, R raised to the power minus 1, together with the unit. The unit is what? Ohms raised to the power minus 1. Here we have L raised to the power minus 1, together with the unit cm raised to the power minus 1, that is per cm. Okay, now what is the, after marking of axis, the next thing you check is what you call your scale, the best scale to use. So for R raised to the power minus 1 axis, we are using what? 2 cm to 0.05 units. 2 cm to 0.05 units. That's the best scale to use. That is exactly what you should use in the hall. 2 cm to 0.05 units. Why in L raised to the power minus 1 axis, which is horizontal axis, we are also making use of the 2 cm now to 0.005 units. 0.005 units. That's what we are making use of. So, how do you plot this graph? It's very easy. The first thing to plot here is 0.033 against 0.023. So, before you plot this, and so that it will be easy for you in the hall, you need to get the value of one line. I've told you, how do you get the value of one line? Easy. Since 2 cm means 10 lines. So since 10 lines is representing 0.05, what will be the value of one line? Just divide this by 10. Divide this by 10. So if you divide this by 10, you have 0.005. That is the value of one line. 0.005. So if I want to plot this in this particular axis and know what the value of 0.033 means, I will simply do 0.033 with my calculator divided by, as easy as that, divided by the value of one small line. If you do that, it will give you whole number. So let's see what that will give us. Now, if you divide this by this, it will give you in whole numbers, the number of lines to count. So what I'm getting here is 6.6. So what does that mean? Anything 0.6, 0.5, 0.7, 0.8, 0.9 in graph plotting, you call it half and half. But anything less than 0.5, that is, you are having 0.4, 0.3, 0.0, 0.1, 0.2. You just take the whole number part. What I mean by that is, for instance, we divided and what we got is 6.2. We are not counting, what we just count is 6 lines, that is all. But in this case, we have 6.6 after dividing. So I will just come here. Remember, this is I'm counting from 0. So the first line is 1, 2. This is 5. We have 6. After 5, we have 6. Between 6 and 7. Between 6 and 7 is the half we are talking about. Are you getting it now? So between 6 and 7 is the half. That is, we now call it 6.5. So if you watch, if you trace it, then that is what we have between that against 0.023. So how do we get 0.023? By knowing the value of one line here. As you can see, 10 line also represent this. So if you divide this by 10, the value of one line for a horizontal axis will be 0.0005. 0.005. So if we want to get the value of this in this axis, what we simply do is 0.023 divided by this. 0.023 divided by 0.0005. It is giving us 46 whole number. So this means that 46 lines here is equivalent to this. As easy as that. 46 lines is equivalent to this. So what we need to do now is we count. Remember, we have gotten for horizontal axis, which is at the middle, 6.5. Now 46 lines, 10, 20, 30, 40. I'll start counting. This is 40. I have 41. The tiny line, 42, 43, 44, up to what? 46. Where 46 meets 6.5 is my point. I will circle it. So that is how you do. You continue and you see, do the rest. Now you can replot this before you enter the hall. Make sure you perfect yourself. Now what we are seeing here is that this electricity practical is a negative graph. So it has a negative slope because it's going this way. But any graph that is going this way is a positive graph. So we have a negative graph is going this way. So the next thing we are told to do here is to get the slope of this particular graph. The slope of the particular graph. So let's see what the slope will give us. We call it the slope S and its intercept on the horizontal axis. In this particular question, we are asked the intercept on the horizontal axis. Are you seeing it now? Then two things now. We have the slope and the intercept on the horizontal axis. So let's quickly calculate that and see what that will give us. Okay, now for the slope, we have, remember, always make sure your points, watch my points. If you are joining your lines, be very, very careful. You check for your line of best fit. What is line of best fit? If you watch what I joined, this entered, I have 5 points, 3, at least 3 must enter. Entry is not the problem, but the points that are entering, are they the best points to enter? That's another question. So we have this point enter, this went out, this point entered, this went out, this side, and this last point entered. So the two that went out different sides of this straight line. That is what we call line of best fit. If you are choosing and the two that enters falls out the same side, you are wrong. That is not the correct line of best fit. So this is a perfect line of best fit. This goes out this way, and this is this way. And they are spaced out, as you can see. These are the things they consider when marking your graph. So let's see. For the slope, come here, check where this is your line, cut the small box into 2. You pick the upper one. So I picked here. You come down again this side and check where it cuts this into 2. I also picked here. If you watch closely in your graph, you are going to see, you might even see some here, but it doesn't matter. I try to make my slope to be very big. your slope has to cover 3/4 of your graph. You can see my slope is very big. So let's do our slope. Slope S is equal to change in r raised power minus 1 divided by changing L raised power minus 1. So what we have is r raised power minus 1, 2 minus 1 this, 1 divided by L raised power minus 1 minus L raised power minus 1 this. So this is what we have. Let's quickly get this. Remember, 2 is always greater than 1. So we are coming this way. So what we have here is, we trace this to this point. There's no much problem here. We don't have much problem. From here to this point is already 0.4. So we have 0.4 minus. Now R1 is down here. You can see. So you trace it to r raised power minus 1 as is. So how do we read this value now? It's easy. We need to just count it in terms of lines. I have from here to here to the 10. This is 10. I have 11, 12, 13 lines. So from here to this point is 13 lines. I will just come to my calculator. Remember, when you are trying to put inside the graph, you are dividing. Now you are trying to remove from the graph, you are going to multiply. So what I'm going to do now is, I have 13 lines times the value of one small line in this axis. But if you are plotting in, you are dividing. And I'm bringing in from whole number now to decimal, I am multiplying. I hope you can see that. So I have 13 times 0.005. So what I have is 0.065. Let's check whether that is true. It is true. 0.065 is between 0.05 and what? 0.10. You can see. So 13 lines is equivalent to what? 0.065. So we are done for the vertical axis. Or the horizontal axis, which is L. So L2 now, remember, this point is for L2. This is L1. So this is bigger. So we are picking this. So remember, the value of one small line in L2 is 0.0005. So anything we get in terms of lines, we multiply by this. So let's count and see how many lines that is equivalent to this point. So we have from here to here is 10, 20, 30, 40, 40, 1, 2, 3, 4, 44. So I have 44 lines times this. So 44 lines times that will give me 0.022. And as you can see, 0.022 falls between 0.020 and 0.025. So this is what we have for this value. Minus, now what is this? We have this point. What do we have? We calculate again 10, 20, 24. So we just punch 24 lines times 0.0005 is giving me 0.012. As easy as that. 0.012. Now that is all for this. We can now use our calculator and calculate the rest. So with our calculator now, we just press 0.4 minus 0.065. That will give us 0.335 divided by 0.022 minus 0.012. This is giving us 0.01. So when we divide this, 0.335 divided by 0.01, we have 35.5. 35.5. What is the unit? This is measured in per ohm cm. Per ohm cm. As easy as that. So this is what we have. Per ohm cm. So if you have any question concerning this, please drop it in the comment section. Okay, lest I forget, we are asked to get the intercept on the horizontal axis, which is L raised to power minus 1 axis. So we just, intercept means where this straight line cuts your horizontal axis. So it is cutting it here. You have to count. This is 10, 20, 30, 40, 41, 42, 43, up to 48. 48. So I will just answer intercept. No matter what they call intercept, they can call it intercept C is, I have 48. The value of one line in this axis is 0.0005. So I will simply say 48 times 0.0005. So that is giving me 0.024 per cm. Per cm. So that is your intercept on the horizontal axis. As you can see, I don't think it will be difficult for us to get intercept on the vertical axis. So we have intercept on the horizontal axis as 0.024. So any question you have concerning this graph, there's no problem. Always remember to subscribe and share so that you keep getting notification each time we upload new video. Thank you.